Om Namah Shivaya. Good morning. Welcome back to inthekhud. This is 13 September 2023, 10:46 a.m. and we are in day 2 of our 3D environment render using Blender. So scatter grass on plane. Plane size matters. No need to be huge. Play with the size of the grass to fill the plane better, not density, more lagged. So you would have seen in yesterday's video. So normally what I would do is come in here, Shift A, Mesh Plane. Let me take it outside. What I would normally do is, okay, you take a plane, you scale it up by 100 or something like that. And then we would do our thing that we apply Control 2 for 2 levels of subdivision. We would come into Modify Stack, apply this, come into the edit mode with edge selection, select all of these, making sure that it's at individual origins. I can say to sphere, make it a perfect sort of circle. Now when you come in here, you will see that the horizon is the way it should be. The problem here was on distributing grass. So compared to what I have right now, the way I've distributed grass is just like using a named attribute here. So if you come into scatter grass, which is all color coded, so it's easier to navigate. What we're doing is we're adding a named attribute grass into the selection so that it's not like doing the whole mesh or anything. The thing is, if you would do it here, right now this has very little geometry on it. What happened to IVCam? Okay, so if I was to select these two faces and assign it to like a vertex group, so I come in here and I select these, you see these are selected. Now with this, if I was to come in here and add a new geometry nodes setup and just quickly distribute points on faces on this, you see, even if I was to take a named attribute and plug sample, whatever it was called, sample here into the selection and Control Shift this, so we see the actual thing as well. You see that the distribution does not only stay here, it goes to these other places as well. And for this is fine. Like if I take the density up, you see the problem that I'm talking about is if I take a very huge plane and then I try to scatter grass in only these places. One is because there is not enough geometry. Even though you take a named attribute and say these are the two faces where you want to go on, it's going to scatter it all over the place because it does some sort of mean calculation, right? So the thing was, with a very huge plane, I wanted it to distribute grass only in this area where my frame is in, but because of this problem where there was lesser geometry, it was distributing it all over the place. The first thing I did is I made the scale of the plane only as far as I wanted to be, like where the trees are going to be and not like far behind. That was the first thing. And the second thing is this plane itself has, I think, 4 or 5 level of subdiv on it, and that I think I have applied. So what that does is that gives us a lot more geometry on the mesh itself, applied geometry, not in like a subdiv or non-destructive modifier. And then you select these and add it to, like, for example, if I come in here, let me shut this geonodes for a minute. If I come into my vertex and I select grass, you select this. So all of this area, this is a vertex group called grass and like a named attribute into that distribution. And then there is a vertex group for soil, which is like this part. So that was one important thing that I learned. Second thing, better understanding sapling tree generator. So I watched a YouTube video, which I will link in the description for credit, but the thing that I was doing wrong about the sapling tree generator add-on is something that I figured. So you're going to come into Shift A, curve, sapling tree generator, and I cannot find it anywhere. Where did it go? This tree here is here. And one more thing is, I said in the last video that you can't really edit it later, but if you press F9, okay, now you can't even do that. It's just one, that's why it's like so painful. So if I do Shift A, curve, and here, if I move around and this for whatever reason goes away, like if I select this and it goes away, I can press F9 and this thing will come up. But you see, it is not something which will stay all the time. You have to keep bringing it up. So it's still a pain no matter what. So the thing that I learned was you come into load preset and select, let's say, Japanese or the fur one, for instance. And you see it just moves out of the local view as well. So as much as I like this add-on, it's just a pain in a lot of ways. Okay, so I bring this here again. See, it keeps going. It's so painful. What was important to learn was branch splitting. You want to bring this branch splitting to 4. because the problem I was facing earlier is like there weren't enough leaves on the tree, which is very important. That was one thing. And you want to come into geometry and bring the curve resolution to 2. So if you were to look at my count here for this particular thing, the faces are 346,000. So it's just very, very high poly, to be honest. You don't want such high poly stuff. So faces from 346,000, I'm going to take it down to, let's say, 2 resolution. So faces come to 243, but these are just trees, so I can even take it down to 1. So it takes the resolution even lesser. And then the other thing I learned is you come in here, and with geometry you come into leaves, and before showing leaves you don't want Blender to crash, so just start with, keep it at rectangular and keep the leaves to 1, and now you show leaves. So you'll get these kind of leaves, okay, like this. And now if you were to come in here again and take this to like 100 or 25, what the default was, then you have enough trees, enough leaves on your trees. And if this is lesser, you can even come in here and make it like 100, I think. Or I think no, you don't want to make this 100. There's a better way to do it. You keep this as 25 and you increase the size of the scale. So leaf scale X, and try and play with this to make it a little bigger. So when you do that, automatically your tree will start to fill in more with leaves. You just play with the general leaf scale instead of leaf scale X. Yeah, so let me bring this down to 2 again. What was the default? Yeah, you generally play with the leaf scale instead of playing with the density, because playing with the density is a bit of a problem. So I'm going to come in here and delete this whole thing. So delete hierarchy. That was point number 2. Instancing trees inside geometry nodes. So if you come in, I'm now going to try and just study this geometry node structure that I made, and we're going to delete these extra things because this is actually my working file. Okay. So here initially what was happening is I had a bunch of tree instances here which I was just manually placing around. What I did is I made a distribution curve, this thing here, tree curve, which if I could solo it, you see this is the tree curve here, which is just starting with a shift A. What I did is I started with shift A mesh single vert, and then just I kept adding those vertices wherever I needed. And the advantage of doing it this way instead of distribute points on faces is you have a lot of control. So if I was to look at my scatter trees here, you see we're taking this tree curve, we're putting that into geometry, and we are instancing on points, so no distribution on faces. Okay, and the advantage of having done that is if I come in here and I would select any vertex, let's say this one, and if I want to shift D and bring it here, that's going to bring another tree out. So that's how the whole structure is working. And again, throughout the scene I've made sure that I'm only working in the camera view with this view in mind. So anything outside of this view I don't want to bother modeling or putting, because the more things that you add, the more it's going to add to the render and the complexity of the scene. So I've been very mindful with that particular thing. Okay, so a curve instance, a better way could be directional. So what I've currently done with this is I've randomly just taken these points and placed around. If I did it a little more directionally, like put a little bit of thought as an index 1 2 3 4 over here, it would help us later. I will show how, because I'm planning to scatter soil on plane. So I took a soil thing from again a soil pile from Sketchfab. If I just solo this, most important thing I've done here is I've added the decimate modifier. So you see, without it there are 230,000 faces on this, and this is a great sort of model with like high quality texture and looks like a pile of soil, as it should. But even if you decimate it to like 0.1, which is reducing it by 100, how much is it reducing? 230,000 to 140,000. So almost like 100x reduce. It is not going to matter so much, but it is going to matter to the fact that because I'm instancing this on the ground, like again with the grass I'm distributing it but on a little lesser number of faces, that's going to help us. So you can even go and apply this decimate modifier, but you can just keep it procedural that way. It's completely okay. So I'm going to switch this off, which is important. Raycast node, make sure trees and soil stay above the ground regardless of plane displacement. This and the geometry proximity node, these are two important things that I learned again from Arundel's BCS geometry nodes course. I've spoken about that course a lot of times. If you want to learn geometry nodes, I think the best starting place is Arundel's BCS geometry nodes course, beginners. It's on canopygames.com. I'll put a link for that in the description as well. Okay, so raycast node, what does raycast node do? It's a very big node, so I've always been very scared of it, but it is here in this pink color box. So raycast node, trees stay above the ground. We take a raycast node, which is this big node. You need a target geometry here. So the analogy for raycast is, let's say you're standing on the top of a highway bridge and you're pointing a torch down at night time. So that torch pointing down, the light is going to go and hit something, right? So that what we are trying to hit, which in this case is this plane here, which we've added displacement to. So that set position thing coming out, that is going to be your target geometry where we're hitting that. Okay, raycast hit, this is giving us some information, is hit position. So we're interested in the hit position. Okay, and this is going to be 0 0 -1 because we're going down, straight down. So what this means is, if this was not, let's say mute, let's say I mute this. Okay, what happens is all these trees, you see, they it's a bit of a task to, yeah, all these trees, they go up like this. Okay, which happens because I've added an additional check here. So by default, let's say your trees were in a different position. What we're doing is we're taking that hit position, like the position at which that ray is hitting, and we're taking that and adding it into the set position of your trees. So set position here, and I think there is something we do to the position, to the source position. So we take the source position of them and we offset it by 10. So again, if I was to unmute this, and if I was to mute that, and I was to mute that, you'll see that trees by default are just going all over the place like this. But what I've done is I've purposely taken the position of those instances and taken it 10 up, right? So that then I can bring it down towards the hit position. Because if by default one of these trees, that's not going to be the case, but if they were underneath the plane that we're trying to hit, what would happen is there would be no ray hitting, because we are hitting rays directly down. So that particular instance won't be affected. So what we do as a good measure is we take all of the instances and we take it up, like a big value up, like that way, and then you hit the ray before hitting. So what this raycast does is, the most beautiful thing is, if I was to come into my my plane here, my displacement, and increase the multiplier, so I would make it more like a mountain kind of situation, whatever, you will see that even though this weirdity kind of thing is happening, our trees always stay on the surface of the plane. It's not very visible because what I'm doing is not very nice. Let me increase or decrease the scale a bit. Yeah, you see here that I'm decreasing the scale. The tree always stays on the top. So exactly the same thing that I've done here for the trees, I've done it for the soil as well, because the soil was going a little underneath the geometry proximity node. This is also another important node. So we have scattered soil here. What I wanted to do is that wherever I have scattered soil, like you see these patches of soil, there I don't want so much of grass to be. Okay, right now our plane is behaving very weird because I changed the displacement. Let me try and fix this. So I think multiplied by 0.5 here. So all over the places wherever you have soil, I want there to be lesser grass. So the way you do that is you take geometry proximity. Now how does geometry proximity work? You have scattered the soil here. We add a geometry proximity node. Now this node requires a target. Target here is going to be the soil. What is it that we are looking at when it comes to? So we're basically affecting the scale of the grass in proximity to the soil. What we do is we convert it into instance to points. Again, this is important because instances directly won't work. You can either realize those instances, and if I was to add a viewer node, I don't quite understand how viewer node works, so I'm going to shift alt. Shift alt is also not working. Yeah, so I just shift alt this. What we have is soil. Now what instance to points does is it makes all of these into point instances. Then what we can do is we can take geometry proximity and we look at the domain of points, so we don't have to realize instances that way, and then we map range it. So this map range is kind of important to know. Let me go back to my main thing. Now over here, map range, this is from min to max and then from min to max. How to read this is distance from minimum to maximum is distance from minimum to maximum is scale. When the distance of the soil from the grass is 0, your scale should be 0.6. If I make this 0, what will happen is all the places where there is soil, there will be absolutely no grass, and that is kind of weird because then it leaves my plane a little too empty. So you can increase it a little bit, and wherever the distance is 1, you want this distance is 1 as in distance is full, and we've clamped it, so like no matter how much the distance is, it will come down to 1. So wherever the distance is 1, like as it's far away from the soil, we will bring the scale to 1. So you will see that because the soil is only distributed in this area here, all of the grass which was over here, which is like consider this as a distance of 1, however far it is, it will be clamped to 1. This will remain unaffected. If you were to come and increase this, you will see that all these which are far away are going to start to increase. It's actually very simple, but I was very confused with geometry proximity and raycast node for a very long time. Now I've added movement to grass. So if I was to come into my camera view again and I was to run the timeline, you'll see that there is subtle kind of a wavy movement happening to the grass. I can play this in my rendered view. It's not playing because we're in cycles. Yeah, you can't really see. So let's play it in the solid view only. So how is this kind of movement achieved? You see scatter grass, and here there should be another frame which says Control J, wind to grass. So what we're basically doing is instance on points, we are rotating those instances, okay? And how are we rotating it? Through a noise texture, and we're adding the position every single time. Here we've added a hashtag frame divided by 30, and the subtract is just to bring the noise texture to the center, 0.5, and that's how we get this Cartesian project, that video I watched. So I'll add that as a disk. Scale and rotate instances. This is something that was the last thing I was trying to figure. The theme of this project is growth, so I wanted to obviously scale those instances. Now for the instance on points, there is a scale thing here, but for the trees I want to add a random value, as in the scale is going from 0 to 0.5. The maximum here was 0.5. To that maximum I've added these things here which are gonna help us scale them up. So we're using index, we're multiplying it by 50 and then we're dividing it by 10. Basically when it's going from 0 to 5, when the value here, this value goes from 0 to 5, we're map ranging it to go from 0 to 0.5. Yes, that's why 50 and 10, because you divide 50 by 10 you're gonna get 5. That's how you're going from 0 to 5. So if I go from 0 to 50 here, what is actually happening is after the map range, we're going from 0 to 5. So when you go from 0 to 5, I want this value to go from 0 to 0.5. Okay, we're going from 0 to 0 to 5. See, it's still increasing sort of. So 0 to 10, let's say 0 to 10. Then these instances are going up, because it's based on the index, right? That goes into max and then that goes into scale. Okay, and again we've put a gray socket into a blue socket. So this blue socket is vector, this is float. We've put a float into scale. What it does is XYZ scale, it gives it all the same value, which is what we want for trees. We don't want like them to be a different value in X, Y or Z, something like that. And the same thing I've done, I tried to do a little different thing for the rotation. So for rotation I was trying to think that if I can be a little smart here with geometry nodes, and I can try and figure out the distance of each of these instances from the camera. So what I did, I took the camera location and I took the position and I subtracted the vector, and this I passed through separate XYZ because I was only trying to look at the Y distance, and then I again did the same thing, multiply, divide, and then map range. So I wanted to rotate it by tau, so that's 6.23 or 2 pi. So what is happening here is if I go from negative 200 to 100, then we're going, I don't quite understand how this is working, to be honest, and these values are also a little too big for my liking, but I think what it's doing is it's starting from here and then going in that direction. I wanted to actually reverse it. That is actually very simple to do. If you just put a subtract here and subtract 1, then I think this should just be reversed. But that is something I've still got to figure out, so we'll probably do that today. Camera culling geonodes not working with instances. This is a tutorial I watched by CG Matter where he deletes geometry based on like the camera culling situation inside of geometry nodes itself, and that's not working with instances. But I think if I convert the instances to points, then it should work, because what happens is, let's say the camera is here, the camera is actually not seeing this particular tree, or is it? So I want to be able to remove all of the geometry which is outside here, even the grass which is outside. I wanted to add to my render. It's all like an optimization task that I'm trying to do. So this is something again I will try to figure today to make it work with instances. Having said that, for today there are a bunch of things that I have to do. I have to first start with AE music storyboarding. So inside After Effects, I'll add a music track for this video, and then I'll divide that into markers, and then we'll see where, like how long each segment of animation has to be. Then I have to add a driver for rotation and scale. There's going to be a driver which is going to drive this scale and rotation at the same time. So I just animate one value and it will even scale the instances and rotate them at the same time, so lesser keyframes. I need a seed 3D model. That seed will fall into a patch of soil. Then there has to be multiple days to night time lapse for the tree growth, so using the sun position add-on. Growth of the center tree from the seed, like that tree has to grow out, which I think it can be an instance in this scene as well, because I'm trying to keep everything in one geonodes tree. Like I like to work this way. You see everything in the scene is working through a geometry nodes modifier. That is the kind of setup I like, not having like everything as separate geometry. Then render optimization, currently in cycles it is taking around 14 seconds to render, and I think I'll have to stick to cycles because for some reason with geometry nodes EV takes longer to render as compared to cycles. So I might as well just stay in cycles and get those natural indirect lighting. Although I will try and see if EV at some point is doing a better job, and I'll try to bake the indirect lighting and do it as well. But this is where we at, so I have to optimize it further for render. Final frame. Again, with the storyboarding you'll come to a point where things have to transition into deforum. So I need the final frame because overnight I have to keep the deforum render, because tomorrow by EOD I have to give this video. I have to replace all of these orange trees with apple trees, which is going to be the segment post the deforum drama happens, and then creating node groups from geonode tree. So this geonode tree that I've made, more or less this is something I have to do every single environment that I make, and even the last time I did it. So this time I did it from scratch, but I'm going to make node groups inside here and put it into a Blender library of mine, where the next time I just shift A and inside my group I'm going to have those node groups here, which I've made here, but it is going to be in my library to use forever. So next time it's like a good head start in especially like distributing things and then scaling instances. I don't want to be doing that every single time, because I even tend to forget. Then I have to go to my inthekhud documentation and learn, and or maybe even go to the Erindel course and figure out how it was done. So that'll be a lot time saving. And again, create asset library for environment renders. This should pretty much solve our environment render 3. One more thing that I wanted to discuss is, other than all of this that I have to figure today for dad's work, I have to upload 17 episodes for show 3, 10 episodes around of show 2. This is something I have to do right now because this is very urgent, and there are like 10 episodes of show 1 making plus upload. So I'm really not sure where I'm gonna fit all of this in today's task list, but that's how life is. I was really concerned about making this video like 10 minutes long, because what is happening is I'm making the video 30 minutes long and then it's taking like 2 hours to bring it down to 15 or 20 minutes. That's not efficient at all. So that's it for today's documentation. Thank you so much for being in the code. I'll catch you tomorrow. Peace.